In a previous tutorial, we talked about the Aristotelian interpretation of universals. And in that discussion, we learned that Aristotle's view of universals involves the implication that there must exist at least one member of every set that's used universally. And that's why across the top here, for the universals, we have x's to indicate that there's at least one s and at least one p. For universal affirmative, it only takes one x because the x is in the region overlapping s and p, which means that there's at least one s and at least one p. For the universal negative, however, we have to have two x's to indicate that there's at least one s and there's at least one p. So, as we pointed out before, this is an aspect of Aristotle's philosophy of science. He does not accept doing science, as it were, on universals that are not instantiated, in other words, that have no existing members. A really simple way to put this is that we can't test anything that we claim, Aristotle thought, about a universal unless we can find an example of it and examine it, right? And there's some truth to that. In our ordinary reasoning, we quite often assume that the universals that we reason with have instantiations, right? So, like if I said to you, all snakes are egg layers, you would naturally assume that there are snakes and there are egg layers because it's part of our common knowledge, right? As we notice, though, things are a little bit different when we try to accommodate categorical logic to a more modern view of science involving hypotheses, right? So what we want to investigate in this tutorial is how the question of existential import affects the immediate inferences that we have just examined, especially the immediate inferences on the square of opposition. So let's start by reviewing the Aristotelian interpretation. Again, the Aristotelian interpretation applies only to universals. Particulars have existence built in anyway, as you can see from some S is P and some S is not P. So on the Aristotelian interpretation, the square of opposition has these various relations: contradictories, contraries and subcontraries, sub-implication and super-implication. Most of these are dependent on the existential import of the Aristotelian interpretation. So, for instance, let's look at an example of sub-implication. If we go from the truth of this universal, all S is P, down to I, some S is P, then clearly if this X is not present, in other words, if there's no existence assumed, then the question is, where's this X going to come from? There won't be an X. So it's obvious that if we shift to the Boolean interpretation, we will end up with a different set of inferences on the square of opposition. So let's have a look at that right now. So here's our square of opposition on the Boolean interpretation. Notice, across the top for universals, we have no x's because we don't take a position on whether S and P exist when we utter a claim like all S is P. So let's look and see which of the inferences on the square of opposition will survive. Let's start with contradictories. If you think about the relationship between no S is P and some S is P, and you think about the fact that if no S is P is true, then the corresponding I must be false. And it must be false because what the E is asserting is that a certain region is empty, and that is inconsistent with where an X would have to be to make the corresponding I true. So it looks like contradiction is not going to be affected, and I will leave it to you to check out the other versions of this, starting with universals being true and looking at the contradictory, and also starting with universals being false and looking at the contradictory. So it looks like initially, we get to keep contradiction. Okay, that's good. Now, what about the rest of the relations? Let's think, for instance, about the relation of sub-implication, which we just talked about. Sub-implication won't survive the Boolean interpretation for the simple reason that if we start at the top and we assume that all S is P is true, that does not guarantee that some S is P is true. And the way we can prove that is by looking at the diagram. The diagram for all S is P, assuming that's true, shows this relationship between S and P. Notice, on the Boolean interpretation, there are no X's. Since there are no X's, then this diagram's information cannot make it true that some S is P. Or to put it another way, if all S is P were true, it does not have to be the case that some S is P is true. So sub-implication is not a valid inference on the Boolean interpretation. So we'll take that one off. All right, so we have seen that on the Boolean interpretation, sub-implication is not a valid inference. So we have to lose that. What about contraries? So contraries are the relation across the top row, the universals, right? And in the traditional Aristotelian square of opposition, contraries cannot both be true, but they might both be false. So think about why they can't both be true. Well, on the Aristotelian interpretation, they can't both be true for the simple reason that if they were both true, where would the shading be? There would be shading across the entire region of S, which means there would be no S's, which contradicts the Aristotelian interpretation of existence, right? But on the Boolean interpretation, there is no such implication for existence, and so it is possible for both all S is P and no S is P to be true. And under what conditions are they true? Under the condition that there are no S's at all. So let's think of a practical example of this, right? All unicorns make good pets. No unicorns make good pets. Both of those two propositions could be said to be true for the simple reason that there are no unicorns. I mean, no actual unicorns, right? I mean, we have pictures of unicorns and we have images and dolls of unicorns, but we don't have any actual unicorns. And because we have no actual unicorns, we have no way to assert either that it's true or that it's false conclusively that all unicorns make good pets or that no unicorns make good pets. So it makes sense when there are none at all for both of those to be true. But if both of those can be true, then we have a problem with subcontraries, because what we said about subcontraries is subcontraries cannot both be false, but they might both be true. But think about it. If the two subcontraries are false, then all that really means is that there are no S's. In other words, it's compatible with what we just found out about contraries, which is that both of the universals can be true if there are no S's. So similarly here with these particulars, so it looks like we now have to lose both contraries and subcontraries. So the only thing left now to consider is superimplication, which goes up. And the only thing to consider there is if it's false, if it's false, that one of the particulars, then can we assert that it has to be false that we have no S is P? So think about some S is not P. So if some S is not P, what would make that false? What would make that false is if it was true that there are no S's. If it was true that there are no S's, then it would be false to say that at least one S is not P. And that's exactly the problem we had with contraries. It is possible that there are no S's, in which case both the contraries I'm sorry, in which case, yes, in which case both the contraries are true. But if that's the case, then we can't reliably go from knowing that the particular is false up to the falseness of the corresponding universal, because it might be the case that both universals are true, in which case we have no S's. So what we learn from this investigation is that the only relation on the square of opposition that survives the Boolean interpretation is contradictories. No other relation survives because all the other relations depend on the existence that is assumed in the Aristotelian interpretation. Now, let's consider this. What about the mechanical transformations? I can leave this to you to prove, but I will tell you that what the diagrams will show, if you look at each one of these, is that we don't actually have a problem with the Boolean interpretation. In fact, in my presentation of the mechanical transformations, I use the Boolean interpretation because it's a more straightforward way to look at the diagrams without the extraneous X's. And so, in effect, the switch from the Aristotelian to the Boolean interpretation has no effect at all on the mechanical transformations. Let me give you an intuitive explanation for this, and you can prove this to yourself with diagrams. So consider, for instance, obversion. In obversion of an A, I'm sorry about that, in obversion of A, okay, let me get a blank sheet here. Get a new screen. It'll be easier. So if we start with A, all S is P, and we do the obverse, what is the obverse? We change the quality, keep the subject term, keep the copulative verb, and use the complement of the predicate term. So notice what we've changed is from A to E. In other words, there is no crossing the boundary between a universal and a particular. What does the crossing the boundary thing mean? Well, it means this. The problem that the Aristotelian to Boolean switch raises is that you can never go from a universal premise down to particular conclusion. If we do that, then we will be assuming the existence of the entities that we're talking about in the universal in order to make the particular work out, right? But in these mechanical operations, we never change from universal to particular. In fact, all the changes take place either stay universal if they start universal, or they stay particular if they start particular. So we are not going to have the Aristotelian Boolean problem. In fact, what this reveals is a really easy way to remember and look for this conflict of interpretations between the Aristotelian and the Boolean. And the way to look for it is to ask yourself, is the argument proceeding from universal premises to a particular conclusion? If the answer is yes, then you have a conflict of interpretations because the existence has to come from somewhere. The existence in the conclusion has to come from somewhere. And if we're using the Boolean interpretation of universals, we don't have existence in the premises. So this is a really good rule of thumb when you're thinking about when you're looking for a sort of signal to tell you that there's a potential conflict. Look for universal premises and a particular conclusion, and you will have a conflict of the Aristotelian and Boolean interpretations. If you don't follow this pattern, then there's no conflict. So for instance, if it's universal to universal conclusion, no problem. Particular to particular conclusion, no problem in terms of the interpretation, but there may be other problems.